Hello, this is Wiz Watson, and my goal is to empower you. So let's look at greatest common factor GCF. It helps if you know your multiplication tables 1 through 12 up to 12 times 12. You know prime factorization and how to build a factor tree. Let's look at the definition for GCF and run through some examples. Greatest common factor GCF is the largest number that a set of numbers have in common. It's the largest number that a set of numbers have in common. Let's look at the first example. So let's find the GCF and look at the following example. I want to find the GCF between 12, 36, and 60. That is the largest number that divides into each one of these numbers evenly. Well, I know that 12 divides into each one of these numbers evenly. So my GCF is 12. And so the easiest way is just to know it. But if you can't know it or you don't know it, we can look at the prime factorization. That is, we break it down, each number down into its primes. And so it's a nifty little tool, and I'll show you how it works. The prime numbers that go into 12 are 4 times 3, which is 2 times 2 times 3. These are all prime numbers. The prime numbers that go into 60, let's look at a factor tree. So I have 60 is 10 times 6. 10 breaks down into 5 times 2. These are prime numbers. And 6 breaks down into 3 times 2. So the prime factorization of 60 is 2 times 2 times 3 times 5. And let's do the same thing for 36. 36 can be 6 times 6. That breaks into 3 times 2. 3 times 2. Those are my 4 prime factors. 2, 2, 3, 3. 2 times 2 times 3 times 3. That is, I want to see what numbers they have in common. So I see the numbers that we have in common are 2 2s and 1 3. So that's 2 times 2 times 3, which equals 12. What we want to look at is the numbers that they have in common. We see we have 2 2s on each one of these, and we have 1 3 on each. So that's how you find the greatest common factor GCF, by breaking it down into prime factorization. Let's look at another example. Let's find the GCF between 28 and 42. Feel free to pause the video. Let's do the prime factorization of 28. Prime factorization of 28 is, we can break that down in a number of ways, but let's go 7 times 4. 7 is already prime. 2 times 2 is prime. Let's look at 42. 42, 3 times 14. Yeah, 3 times 14. Is that correct? Yeah, 3 times 14. Well, 3 is already prime. And 14 is 7 times 2. So what numbers do they have in common? We have a 2 and a 7. So the GCF for 28 and 42 is 2 times 7, which is 14. So remember, that says that 14 is the largest number that divides into both 28 and 42 evenly. So feel free to pause the video and try the following example. I want to find a GCF between 76 and 86. I'm going to go with prime factorization. And one of the little tricks that I use, one of the secrets that I use, if I don't know how to factor a number, I always look for patterns. I know 76 is an even number, so I can divide that by 2. I'm going to start with 2 times, 38. 38. 2 is already prime. 38 is 19 times 2. So that's the prime factorization of 76. Let's look at 86. I'm going to do the same thing. It's an even number. I'm going to factor it into 2 times, 43. 43 is prime, and so is 2. So I see that the greatest common factor, GCF, is just 2. That's the largest number that divides into both 76 and 86. Feel free to pause the video and try the following example. I have 12 and 33. We're going to do the same thing. Factor tree. 12 is just 4 times 3. That's prime. And this is just 2 times 2, all primes. 33 is 11 times 3, both prime. We see the common number is 3, so the GCF is 3. Feel free to pause the video and try the following example. I have 121 and 280. We're going to do the same thing, 121. Let me erase that. 121. I know 121 is 11 times 11, both prime. I have 280. 280. I can see it has a 0 on the end. I'm looking at the pattern. So I'm going to break that down into 28 times 10. 10 is just 5 times 2. 28 is 7 times 4. This prime, prime, prime. 4 is 2 times 2, both prime. So we can see that these two numbers have no common factors, and they're said to be relatively prime. That is, they're prime in relationship to each other. So feel free to pause the video and try to find a GCF between 64 and 144. Best thing to do is build a factor tree. I'm going to go 16 times 4. 16 is just 8 times 2. 8 factors into 4 times 2, which factors into 2 times 2. All of these are prime. 4 factors into 2 times 2, all prime. Now, let's look at 144. That's 12 times 12. 4 times 3. 4 times 3. 3's are both prime. 4 is 2 times 2. 2 times 2. My common factors are 4 2's on each. So my GCF is 2 times 2 times 2 times 2. But that's 16. So my GCF for this one is 16. Now still 16 divides into 64 and 144 evenly. Feel free to pause the video and try the following example. I want to find GCF between 51 and 77. So 51, what is that? 3 times 17. And these are both prime. So let's look at 77. That's 7 times 11, both prime. We see that they have no common factors, so these are relatively prime. So that's how you find GCF. I like to point out the most important step here is to practice. So when you practice a concept as soon as you learn it if possible, but you never want to wait days before you practice the concept. That's just too long. And by that point you will have forgotten most of it. And remember to always check your answers, but realize that even when you check your answers on a test or whatever, you still may have some mistakes, so don't be so hard on yourself. Hopefully this video was helpful to you. Please like, subscribe, share, support.